Lesson 14.1, Task 1. Explore recursive formulas for an arithmetic sequence. In the previous module, you used explicit formulas such as a of n equals 2 plus 3 times n to represent sequences. An explicit formula gives the nth term, a of n, as a function of the term's position number n in the sequence. In this lesson, you will learn how to define a sequence using a recursive formula. A recursive formula gives the beginning term or terms of a sequence and a recursive equation that tells you the nth term, a of n, is related to one or more preceding terms. Use this recursive formula for a sequence. A of 1 equals 3, so our first term is 3, and a of n equals a times n minus 1 plus 5. So, it says, explain in words how to find a term of the sequence using one or more of the preceding terms. Alright, so if you have one or more of the preceding terms, you would simply add the common difference to get to the next term, and you would keep adding the common difference to get to the next term and the next term and the next term, because remember, an arithmetic sequence means there is a common difference, so you can add the same number to get to the next term. Alright, it says enter the term numbers 1 through 10 in column A of a spreadsheet as shown. In cell B2, enter the first term of the sequence. So here's B2. B2 is the first term. Remember, the first term was 3, and that was given here as the first term equals 3. So a of 1 equals 3. Alright, so it says in cell B3, enter the formula B2 plus 5. So B2 is 3, so 3 plus 5. So you add your common difference to get the next term. Okay, so that one's going to be 8, and then we add 5 again and add 5 again. So you're adding 5 to the previous term. So we would have B3 plus 5, B4 plus 5, B5 plus 5, and so on and so on. Alright, it says, what type of sequence do the terms form? How do you know? Alright, they form an arithmetic sequence because you're adding the same common difference each time. I know because consecutive terms of the sequence have a common difference of 5. Alright, so it says, what is an explicit formula for the sequence? Alright, so remember you're going to do the previous term. So for a recursive formula, we're going to have the previous term, not the first term. Remember, a of 1 is your first term. So I have to take 3 and go back 5. So my first term, a of n minus 1, means the term before my first term. Alright, so this is just the notation for that. So if I go 5, and instead of adding 5, if I take 3, instead of adding 5 to get 8, to get my next term, to get my previous term, I'm going to subtract 5. So 3 minus 5 gives me negative 2. So I'm going to have negative 2 plus 5 times n. So negative 2 plus 5 times n. And you still used your common difference. You just have to use it to find the previous term instead of using the first term. Alright, so it says use the explicit formula to write a formula in cell C2 of the spreadsheet for calculating the first term of the sequence. The formula in cell C2 should use the term number of the cell A2. Fill down the formula from cell C2 to cell C11 to find the first 10 terms of the sequence. Do the terms you found in column C using the explicit formula. Match the terms you found in column B using the recursive formula. Yes, they should match. Alright, so basically what that's saying is if you want to go back up here to the spreadsheet, right here you're using the recursive formula. If you want to go up here and use the explicit formula, then all you want to do is double check and see if you get the same answers from each one of those. That just gives you some practice using the two different types of formulas simultaneously. All right, so in general, what is the recursive equation for an arithmetic sequence with common difference d? So it's going to be your previous term plus your common difference. And the reason we're choosing this one and not the first one is because it says in general. So in general, you're going to use your previous term plus your common difference. All right, suppose you need to find the 200th term of a sequence without a spreadsheet or a calculator. Which type of formula for the sequence, an explicit formula or a recursive formula, would be more helpful, and why? An explicit formula because it gives the nth term as a function of the term's position, number, n in the sequence. A recursive formula because you can add d as many times as you need to reach the nth term. All right, so even though you can do this, do you want to do that 200 times? And then what if you lose count and you have to start over? So in a case like the 200th term, an explicit formula is definitely going to be the best choice. All right, so it says, what is the 200th term of the sequence you worked with in this task? All right, so if we look and we've got a sub n equals a times the previous term plus your common difference. In this case, we know that we want to find the 200th term. We know that the previous term was -2 plus 5n, and that just is bringing this all together. So our previous term, remember, we started with 3, and if you go back 5 from 3, it gives you -2. So a of 200 equals -2 plus 5 times 200. And we can pull up the calculator and see what that says. All right, so -2 plus 5 times 200. 998. So the 200th term is 998. And you can see that that was much easier to find that using the recursive formula than adding the common difference that many times. All right, that's all for task 1. If you have any questions, let me know. Lesson 14.1, task 2. Write recursive formulas for an arithmetic sequence. A recursive equation for an arithmetic sequence with common difference d is a of n equals a times n minus 1 plus d in function notation, or a sub n equals a sub n minus 1 plus d in subscript notation. You can write a recursive formula for an arithmetic sequence given a graph, a table, or 2 terms. All right, question 2. Write a recursive formula for the sequence whose graph is shown. All right, so it says the terms of the sequence are the y-coordinates of the points. All right, so the y-coordinates are the vertical axis, so you can see that this one is -5, -3, -1, 1, 3, 5. There is a common difference of 2, so the sequence is arithmetic. Using subscript notation, you can write a recursive formula for the sequence as a sub 1 equals 5, so your first term is -5. A sub n equals a sub n minus 1 plus 2. All right, so that's your recursive formula. And again, this is in subscript notation. Remember, subscript means the number is supposed to be small and set kind of below the variable, even though it doesn't look like it here. Here it kind of looks like it's kind of sets down a little bit, but a subscript should be smaller and kind of set underneath everything else. All right, it says, how can you tell from the graph that the sequence is arithmetic? All right, you can tell the sequence is arithmetic because if you remember, this would have The fact that they fall in a line, it looks like they have the same slope. So the fact that those are in a line tells you that it's arithmetic. So the horizontal coordinate of the point is the position number of the term. The vertical coordinate of the point is the term itself. The points on the graph are the terms of the sequence. The points lie on a line. All right, so that should make sense. If it has a common difference, that means it changes the same each time, which is the same as if you have a slope that changes the same each time. All right, how can you write a recursive formula in function notation? All right, so we've got a of 1 equals -5. That's our first term. And then we've got a of n equals a times n minus 1, and then plus our common difference. And if we remember, our common difference here was 2. So our common difference is 2. All right, that's all for task 2. If you have any questions, let me know.